Hey guys, welcome to our first flipped video lesson of the second half of Unit 2. The first half we talked about equations. This half we're going to talk about inequalities. Well, there's good news about solving our single variable linear inequalities, and that's pretty much that almost everything is going to be exactly the same as when we solved our single variable linear equations. Let's do a quick recap of the things we learned to solve our single variable linear equations. Right? We learned how to deal with fractions in our equations, with parentheses, with like terms on the same side, with variable terms on both sides. With our two-step equations, we cancel the constant, we cancel the coefficient, and we would have our solution. Right? Here's a quick recap of a problem here. You can see we have fractions, so we use the least common multiple canon, multiply 21 by everything, and we'd get our equation we have below there. You can see then we distribute the negative 63. I combine like terms on the left-hand side with the constants, add 63x to both sides, add 189 to both sides, and then divide both sides by 89 to get my solution there. We're going to be taking all of these skills and we're carrying them into our linear inequalities. However, there will be some differences now that we're dealing with expressions being not equal to each other rather than equal to each other. First thing we've got to talk about is a new symbol or set of symbols, because we can't use an equal sign anymore because the right hand and left hand side aren't going to be equal. Here are our four symbols. Maybe they're not new to you, but if they are, go ahead and take a second and write these down. Make sure they're in your notes so you can recognize them. We have greater than and less than. We have greater than or equal to and less than or equal to. An easy way to remember the names is we read from left to right. So as you're reading an inequality and you hit the inequality symbol, if you hit the open, the big end first, the greater side, that's a greater than. If you hit the closed end or the smaller side, that's the less than symbol first. So let's think about our inequality here. X is greater than 7. As I go from left to right, I hit the open end first, so I know that that's greater than 7. What numbers could make that true? Well, there's a lot of them, right? 8, 9, 10, 14, 74, 912, 1034, 3690, and the list could just keep going. Well, how many numbers could it keep going for? How many numbers could I put in for x, substitute for x, to make this inequality true? And the answer is an infinite amount of numbers. Now, if you remember, that was our definition of a solution, something that makes an equation true. Well, we're going to carry that same definition with inequalities. A solution to an inequality is anything that makes our inequality true, that makes the statement correct. In this case, it's not that the sides are equal to each other, it's that the left-hand side is going to be greater than the right-hand side. And what we're dealing with when we have our solutions of our inequalities, we're not just going to have one or two solutions now. We're going to have an infinite number of solutions for any inequality that we solve. This is not a special situation like it was with our equations. This is now kind of the normal solution set that we're going to have. Also, our method for finding our solutions is going to remain the same. Isolate the variable. Remember, all the steps that we talked about just on the last slide, that's going to be the same stuff we're doing now. Well, this leads us into our two big differences in actually solving our single variable linear inequalities. The first difference, if you multiply or divide a negative number on each side of an inequality, you must ... Well, let's take a look at an example before we finish this sentence here. So if I have the inequality negative 5x is greater than 25, and I divide both sides by negative 5, like we did in our last part of the unit, we get x is greater than negative 5. This means 1 should be a solution, because 1 is greater than negative 5. But when I substitute 1 back in for x, notice I get that negative 5 is greater than 25. That's not a true statement. So what that tells us is 1 can't be a solution. So there has to be something we need to do in this situation, because solving it like we did in the first part of the unit isn't giving us a solution. Well, let's look what happens when we change something with our inequality sign. So when I divided by negative 5, notice the greater than symbol changed there. This now tells me that x is less than negative 5. So negative 6 would be a solution. Well, let's check it out here. We plug negative 6 in. 30 is greater than 25. That's true, which means 6 is a solution. So what happened here? What did we have to do to make sure we ended up with a solution in this situation when we divided both sides by a negative? we had to flip the inequality sign. This is the most often forgotten about step in solving our single variable linear inequality. So please, please, please really stick this in your brain, shove it in there, file it away so it doesn't get out, and remember this difference here. Okay, our second big difference is that now that we have an infinite number of solutions, we are going to be representing our solutions in the form of a graph. Right? We're going to be taking a number line and graphing our solutions. A couple things we have to know about graphing inequalities. The first is that if we use a greater than or a less than symbol in our inequality, we need to represent the first number that we are starting our solution set with an open circle. Okay, we can see we put an open circle at 5. It's x is greater than 5, so then I drew an arrow going to the right to the numbers that are greater than 5. Now, what does this open circle mean? Well, this open circle means that 5 is where we start our solution set, but 5 is not included in our solution set. 5 is not a solution to this inequality here. I'm sorry, guys. This comes up every time, and I don't know how to make it go away for good. But 5 is not part of our solution. Well, what happens if we have a greater than or equal to or less than or equal to, such as x is less than or equal to -3? Well, now we're going to put a closed circle at -3. And we went to the left because we're looking for the numbers that are less than -3. What the closed circle means is not only are we starting at that value, but that value is included in our solutions. So on the right, -3 would be a solution. 5 on the left would not be. Also notice the number line. We put an integer to 1 tick to the right and 1 tick to the left of the number that we started at. We don't need to put 100 tick marks. We don't need to find 0. We just want 3 tick marks with an integer to the right and an integer to the left of the number that we're starting our graphs at. Well, if you have questions about this, please make sure you write them down and come to class tomorrow, because we're ready to start solving our inequalities. We've talked about what a solution is, how to find the solution, and a couple of differences in all of our steps. So now let's actually put that into practice. In A here, we got 5x minus 9 is greater than 11. This is a two-step inequality. So I add 9 to both sides, divide by 5 on both sides, and graph my solutions here on my number line. Okay, for B, it's a little more complicated. We have a few more steps here. I've got to distribute the 2. I've got to combine the like terms on the right-hand side of my inequality. I've got variable terms on both sides, so I've got to subtract 2x from both sides. And now it's a two-step inequality again. Subtract 8 from both sides, divide by 2, and I'm going to get -8 is less than or equal to x. When I graph this, though, I've got to be careful. I am looking for the numbers. If -8 is less than x, what I'm really looking for are the numbers that are bigger than -8, right? So I put a closed circle at -8 and draw my arrow to the left. A lot of times we can think of the inequality symbols as an arrow in which way to graph our inequalities, to draw our lines. If you notice in A, the arrow kind of points to the right and we drew our graph to the right. But in B, our arrow, the inequality, kind of points to the left, but we ended up having to graph to the right. We can't always take the inequality as if it were an arrow pointing to which direction to draw our graph. We've got to make sure we really think about what the inequality is asking us and what numbers would be a solution for our inequalities there when we graph. Okay, our last one, C, we've got to flip our inequality sign because I divided both sides by -6. Again, it's a closed circle at -5, and we're looking for less than -5, so we're going to the left. Again, notice in every graph I have the starting point with an integer to the right and an integer to the left. Well, if you need to take a couple of seconds to pause this, to rewind, to get all this work written down, to think about it, to see what we did, and again, if you got questions, write them down, bring them to class, do that, but we're going to move on right now to having you try them on your own. So here are 3 inequalities. I want you to write these down. They should be in your notes. Please, please, please show us the work that you're doing. We're not going to show you the work here when we come back. So try these on your own, show us the work, and then we'll check our answers. Ready? Pause. Welcome back. Let's see how you did here. So the first one we should have gotten h is less than or equal to -5, and we can see the correct graph there. And the second one we should have gotten x is greater than 3, and we can see the graph of those solutions. And then our last one, I added an extra one step here. We need to get rid of the fractions by multiplying by 35, which is our least common multiple. And then I would end up with a fraction here. K is less than -151 over 115. Now, when we're trying to put this on a number line, I'm okay with us putting this as a decimal to know where this should go. This is negative 1.31 as a decimal, which means it would go in between the integers negative 1 and negative 2. Notice the number, the tick mark to the right and left, are not decimals, they're integers, right? And since it's less than, and we need an open circle going to the left there. Well, that brings us to the end of our video. Hopefully, you learned some things here. Hopefully, some things are making sense. If they're not, please, guys, ask the questions when you get to class, and we'll talk about them and make sure you got some good understanding. Well, until next time, we'll see you later.